Hello everyone, so welcome to the first live session. In this video I shall be discussing with the limits, continuity and differentiability. Actually I believe that this will be a better method because I shall be able to take the sessions for long, and moreover it is not also possible for you to ask in the comments the mathematical doubts. So I shall be taking a special live session in the evening every day for the doubts. So now let us begin with the first session. So first of all, let us revise quickly the formulas and the important theoretical concepts for the chapter limits, then continuity, then differentiability. I shall also take some important question for functions on it. So first of all, let us begin with the limits. The most important formula which you must know for the limits is Maclaren's formula, or basically Maclaren's theorem, because it will be used extensively in deriving all the equations, all the theory that you have learned. So first of all, what it says is that whenever we have any function f of x, okay, so f of x is given to us like e raised to power x or sine x or something like that, it can be written as f of 0 plus x into f dash 0 by 1 factorial, that will be equal to 1. So here also you can say that f of 0 upon 0 factorial, so that also will be equal to 1, plus x square upon 2 factorial into f double dash 0, that implies the 2 time differentiation of f of x by putting x is equal to 0, plus we move on till x raised to power n by n factorial into f raised to power n dash upon 0. Basically we differentiate here n times. Now let me tell you with the help of an example that what it actually does for us. So let me take example where f of x is equal to e raised to power x. Okay, so we have been given f of x as this. Now we want to derive this series expansion for e raised to power x. So how we can derive it? So f of 0, just find these values. First of all, we find the value of f of 0. So the value of f of 0 comes out to be e raised to power 0, which will be equal to 1. Now f dash 0 will be equal to what? That will be equal to again the differentiation of this thing, that will be equal to e raised to power x, and we have to put 0 finally after differentiation, that will be equal to once again 1. Similarly, if you do f double dash 0, that will also come out to be 1 because the differentiation of e raised to power x remains the same. Okay, so similarly f n dash 0 will also be equal to 1. Okay, so I hope you have realized that how we are putting the values here. So from here, the expansion, that is f of x is equal to e raised to power x, we just put the value here. So e raised to power x comes out to be f of 0, that is equal to 1, plus x by 1 factorial, that is equal to 1, into f dash 0, that is also equal to 1, into 1, plus x square upon 2 factorial, that will be equal to 2, into f double dash 0, that will be equal to what? That will be equal to 1 once again, into 1, plus we move on to the last term, which is x raised to power n upon n factorial, that will be equal to n factorial only because we don't know the value of n, into f n dash 0, that also be equal to 1. So the series expansion of e raised to power x can be written as 1 plus x square by 2 plus x cube by 3 factorial, that will be equal to 6, moving on till x raised to power n by n factorial. So this is how you derive the formula for the series expansion of any function that is given to us. I'll take one more example because the reason is that many people just know about the what we say L hospital rules or L hospital rule basically, and they think that they know the chapter limits, but it is not the case. I'll be showing you in this video that everything is more important for JEE Advanced. Now let me take one more example to show you that how it is done actually. One more common function like f of x is equal to sine x. So let me take it. I will be showing that how to derive for it and then moving on to the important questions for it. So f of x is equal to sine x. Here f of 0, the first mission is to find f of 0, that will be equal to sine 0, which will be equal to 0. The next step is we need to find f dash x first of all. So f dash x will be equal to cos x, which implies f dash 0 will be equal to cos 0, which will be equal to 1. Let us move on to find the next one, that is f double dash x. So f double dash x will be equal to what? That is the differentiation of this term, which will be equal to minus sine x. So from here we get the value of f double dash 0 is equal to 0. Now let us find the triple differentiation. So the triple differentiation will be equal to what? That is the differentiation of this thing, which will be equal to minus cos x, and from here f triple dash 0 will be equal to minus 1. Okay, so I hope till this is enough to show you that how to derive it. So now let us put in the formula for sin x. The f of x is equal to sin x here. So sin x comes out to be f of 0. F of 0 is equal to 0. Okay, similarly now we have to put x by 1 factorial into what? Into f dash 0. F dash 0 here is 1 into 1. Okay, plus x square by 2 factorial into f double dash 0, that is equal to 0. The next term is we have to put x cube by 3 factorial, that is equal to 6, into f triple dash 0, that is equal to minus 1, and similarly so on we can solve it. So we get the value of sin x to be x plus 0 minus x cube by 6, and similarly x raised to power 5 by 5 factorial, and so on. Okay, so this is how you derive the value of the series expansion for any function that can be given. Any arbitrary function can be given in the JEE advanced exam. So this is why I've discussed that how to derive it. This Maclaren's formula is very important even after coming to IIT. So this should be known to you. Now let us move on to the second part where I shall be dealing with the questions for limits. So this is my first question for the video, a very important question. Because why is it important? These type of questions are favorite for JEE Advanced, where you have the questions which deals with 2 or more chapters simultaneously. Here we have limits, here we have functions, here we have trigonometry. So once again a very important question for JEE Advanced. So let us see that how to solve it. So let us begin with the answer. So we have f of x to be equal to tan x by 2 into sec x plus tan x by 2 square into sec x by 2. Basically what is happening? X by 2, x by 4, similarly x by 8, that is a GP. Similarly here sec x by 2, and so on. We have been given that f of x is equal to this till n terms, and moreover we have been also given that g of x is equal to tan x by 2 raised to power n plus f of x. Then we need to find the value of limit of x tends towards 0, g of x upon x raised to power 1 by x. So for solving this, what we need is that we should know the value of g of x. Okay, so for knowing the value of g of x, you can see that we should know the value of f of x. So let us begin by finding the value of f of x. So f of x is given to me as these terms. So tan x by 2 into sec x plus tan x by 2 square into sec x by 2. Similarly, if we move on to the last term, we can see that the last term will be written as what? This is also one more important thing. Sequence and series is also involved here. So x by 2 square, that is the first term has x by 2 raised to power 1, then 2 raised to power 2. Similarly, the nth term will have x by 2 raised to power n. Okay. Now let us deal with the sec x terms. So sec x, here we have x by 2 raised to power 0 basically we can say, because x by 1 will be equal to x by 2 raised to power 0. Now if we have sec x by 2, sec x by 2 implies that it will have sec x by 2 raised to power 1. Okay, similarly the last term will be equal to what? X by 2 raised to power, see, n minus 1, because here n is equal to 1, then 1 minus 1 will give me 0. Here n is equal to 2, so we have 2 minus 1 is equal to 1. Similarly in the last case we will have 2 raised to power n minus 1. Okay, so now let us deal with this one first of all, this term which is given to us here. So this term, because we need to simplify this in order to get to a particular result. Learn these type of techniques, because I will say that approximately 1 to 2 questions every year can be seen on these type of techniques that I am going to teach you here. So that's why I have taken this very important question. There are certain reasons for taking the question. So tan x by 2 into sec x, the first term which is shown in red here, we have written it here. Okay, now we can see that the tan x by 2 can be written as sin x by 2 upon cos x by 2. Remember my one thing for trigonometry chapter also, that whenever tan, cot is creating a problem, try to convert them into sin and cos, because that will eventually make the question easier for you. And similarly the sec x which is written here can be written as 1 by cos x. Okay, so I hope that this is clear that what I am doing actually. So sin x, this has been written here, this has been written here. Okay, so now we can see that we need to resolve this, that is sin x by 2 upon cos x by 2 into cos x. Now you people need to think that we have cos x by 2 into cos x and we have this term here. Now how can we resolve this? The sine into cos terms, like you have to think about it. So we know a formula that sine of a minus b will have two different cos in it, because whenever we have things in division or product form, it is generally easier to take them out in the sum form. Whenever we have product form, try to convert it into sum form. Why is it so? Because the sum form will have like a plus b, and similarly this term would have something, let me say this is a minus b, this will have b minus c, the next term would have maybe c minus d. So basically these type of things cancel out. So once again you can see that the importance of this question: trigonometry, functions, limits, and moreover sequence and series. So whenever in sequence and series type questions the product form has been given to you, try to convert it into the sum form. This is my basic experience from 2 to 3 years in mathematics. So what I mean to say here is that we have sine x by 2. So it can be written as sine of x minus x by 2, because x minus x by 2 is equal to, once again, x by 2, which is shown here, upon the cos x by 2 into cos x. Okay, so I think you're able to realize. Now I shall be using the sine a minus b formula here. So what is sine a minus b? Sine of a minus b, that is sine a into cos b minus cos a into sine b, okay, upon cos of x by 2 into cos x. Now the next thing is that this thing, the above, the numerator term can be divided by this thing here, that is, I hope you're able to see that what I'm doing here. So sine x into cos x by 2 upon cos x by 2 into cos x minus cos x into sine x by 2 upon cos x by 2 into cos x. Okay, so I've just distributed the denominator here. Cos x by 2 gets cancelled here. From here cos x and cos x gets cancelled. So basically what I've done is that this term, the tan x by 2 into sec x, the first term can be resolved into what? That is tan x sin x by cos x minus tan x by 2. Now let us resolve the second part for this question. Okay, the second part here. Now we have resolved for the first part in this manner. Let me take it to be equation 1. Now we need to find the second term, which is tan x by 2 raised to power 2 into sec x by 2. So let us see that how we can do this one. So once again we have to write it in form of sine and cos. So tan x by 2 whole square will become sine of x by 4 upon cos of x by 4. Okay. Now sec x by 2 will become 1 by cos x by 2. Now let us see how we can resolve it further. So once again x by 4 is given to us. We need to resolve it into the terms which are given to us in the lower section, because the denominator and the numerator has to get somewhere cancelled. So basically we need to have some common terms in both the places. So what I do actually here is that how x by 4 can be written in terms of x by 4 and x by 2, you need to think it. So that will be written as sine of x by 2 minus x by 4, okay, upon cos x by 4 into cos x by 2. Now we can see further from here that sine x by 2 minus x by 4, once again sine of a minus b will be used here. So that will be equal to sine a into cos b minus cos a, that is cos x by 2 into sine b. So this will be written. Now once again distributing the numerator down. So cos x by 4 into cos x by 2, and here also once again we write it cos x by 4 into cos x by 2. So now we cancel these terms here. Once again you can see the common terms which are written. So this thing can be resolved into tan x by 2 minus tan x by 4. Okay, so on the previous page we had derived that tan x by 2, tan x minus tan x by 2 can be derived for the first one. For the second one we can derive this. So to write it generally we can write it as the first term will be resolved into tan x minus tan x by 2. The second term will be resolved into tan x by 2 minus tan x by 4. Similarly, you can guess what the third term will be resolved into. The third term will be resolved into tan x by 4 minus tan x by 8. I hope the point is clear. Now similarly, we move on to the last term, that is basically the nth term that we are taking into consideration. So what can the nth term be resolved into? You can see the pattern here. So it was x by 2 raised to power 0. So in the last term we will have tan of x by 2 raised to power n minus 1, because when n was 1 here, it became 1 minus 1, that is 0, minus tan of x by 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, so 2x by 2 raised to power n. Now this thing is basically what? This thing is basically the sum of all the terms which was given, and that was equal to f of x. We have taken this. So f of x will be equal to these things that is given here, that are given here. Now let us cancel the terms which are taken. This term gets cancelled, this term gets cancelled. Similarly, this and this somewhere here gets cancelled, and moving on, this will get cancelled. So f of x can be written as tan x by 2 raised to power 0, that is 1, minus tan x by 2 raised to power n. So till now we have just derived the value of f of x. So in the question it was given to us that f of x is this and g of x is this. So we need to find the value of g of x now. So in the question it has been mentioned that g of x is equal to tan x by 2 raised to power n plus f of x. We have found out the value of f of x to be tan x minus tan x by 2 raised to power n. So let us substitute this value into this part. So if you substitute this value into this part, we will get g of x to be equal to tan x by 2 raised to power n plus tan x minus tan x by 2 raised to power n. So this and this will get cancelled. So the value of g of x comes out to be tan x. Okay, so we have derived the value of g of x. Now the question was that we need to find out the value of limit x tending towards 0, g of x by x raised to power 1 by x. So let us see to it. So see that it is such a long question, but the final answer, the g of x comes out to be tan x, which is not expected at all if you are solving it for the first time. So that is why you should know that how to resolve the trigonometric functions into other parts, and moreover how to take them into limits. So the first part is limit x tending towards 0, g of x upon x. So g of x is equal to what? Tan x upon x raised to power 1 by x. We need to find the value of this. So x tending towards 0, the value of tan x by x tends to 1, and the value here tends to infinity. Okay, so here we have basically tending to 1 raised to power tending to infinity, basically the 1 raised to power infinity form, which is a very cliche type of question. So it can be resolved into e raised to power f of x, that is this, f of x minus 1 into g of x. G of x here is 1 by x. So let us resolve it here. So it can be written as, and limit x tends towards 0. Now you don't need to write everywhere here, I have written just for this part. So it will be equal to tan x minus x by x square. So now you can see that limit x tends towards 0, this tends to 0, and this tends to 0. So what we can apply here is that the L'Hopital rule can be applied. So differentiating the above one, we get sec square x minus 1 upon 2x. Now if you apply the L'Hopital once again, why? Because if you put 0 here, we'll get this value to be 1. So again it becomes 0 by 0. So once again we have to differentiate it. So e raised to power sec square x differentiation is 2 sec x, and the differentiation of sec x turns out to be sec x into tan x. So sec x into tan x upon 2. Okay, so we can see here that the 2 and 2 gets cancelled, and tending limit x tends towards 0, this thing will become 1 into 1, and this thing will become 0. So this thing is equal to 0. So we get e raised to power 0. So the final answer comes out to be 1, which is totally unexpected. This could have been a very good integer type question. So that is why you should know how to solve it. Now the second part is limit x tend towards 0, and we have g of x by x raised to power 1 by x square. So now let us solve this part first of all. So g of x was tan x, so let us put it here. So tan x upon x raised to power 1 by x square Once again, if you see, it becomes tending towards 1 raised to power tending towards infinity. So it becomes e raised to power tan x by x minus 1 into 1 by x square. So now it can be resolved into e raised to power tan x minus x by x cube. So once again 0 by 0. So 0 by 0. Now once again we have to resolve it further. So how it can be resolved? It will be equal to e raised to power sec square x minus 1 upon 3x square, which is once again 0 by 0. So it can be resolved into e raised to power 2 sec x into sec x into tan x upon 6x. Okay, now you can see that this becomes 0 by 0 here. Now this tan x upon x when x tends towards 0 is equal to 1. So this equals to 1. Sec x into sec x will also be equal to 1 because x tends towards 0. So e raised to power 2 by 6. So what is e raised to power 2 by 6? The final answer comes out to be e raised to power 1 by 3. So this is the answer for the second part. Now let us move on to our next question. Now the second question which I have taken for this video is from the chapter continuity. So we have been given a function x where we have the split function, that is, this is the greatest integer of cos pi x. Let me say here, this is equal to greatest integer of function. So this is cos pi x and this is the modulus of 2x minus 3. Here the value of x belongs from 0 to 1. Here the value of x belongs from 1 to 3. Now this is a fairly easy question if you see, but this can be asked in advance because we have the greatest integer function evolved here. So the first type is cos pi x. Let us deal with the cos pi x first of all. So the greatest integer of cos pi x is given to us. So now we know that whenever we have greatest integer of any function of x where it becomes discontinuous, it is given even in the NCERT. So whenever we have the greatest integer function of any function, it becomes discontinuous at integer points. Okay, like we have the greatest integer of x, it becomes discontinuous at which points? The points which are integers. So what are the integer points? Like -1, -2, -3, etc. moving on till wherever you want to go, 0, 1, 2, 3, etc. So similarly we have to see for here also. Now we have one restriction also, that x should belong from 0 to 1. So let us put first of all this function to be equal to anything which you want. Like if you say this function to be equal to, let me say -1 first of all, you can take it to be equal to anything where the x belongs from 0 to 1. That should be the condition. So if the greatest integer of cos pi x is equal to -1, it implies that what we have from the inside, see, we have to take the greatest integer of function is equal to -1. So cos pi x will be equal to -1. So cos of pi x will be equal to cos of pi, because cos pi is equal to -1. So from here pi x will be equal to pi. Why aren't we taking the general solution here? Why only the principal solution or whatever we want to take according to the condition? Because the value of x is restricted. We don't have infinite values for x. So if you take any value like the other terms like 3 pi here, so we get the value of x to be equal to 3, which is not in the given condition. So that will be useless for us. So from here the value of x comes out to be 1. So the first point of discontinuity for this function is x is equal to 1. Now let us move on to the second point for this function, that is the cos pi x has to become an integer. So let us take the integer function to be 0. It can be taken anything according to your wish. You can verify it to be at -2, 0, 1, anything, but that condition should satisfy x belongs to 0 to 1. So from here the cos pi x will be equal to cos of pi by 2, the principal function I'm taking. You can take the general solution, but that won't be helpful for us. So pi x will be equal to pi by 2. It implies that x is equal to 1 by 2, which is once again in the domain which is given to us. Remember that whenever you're trying to solve any mathematical question in JEE Advanced, always focus on the domain. I've told you many times. Yesterday also we discussed the question on the group, so there also I told you. So the next I want to take is cos pi x is equal to 1, which is in turn equal to cos 0. So from here we have pi x is equal to 0, and in turn we get x is equal to 0, which once again lies in the range which is given to us, the domain that is given to us. Now if you want to take cos pi x is equal to 2, Is that possible? That is not possible because the range of the function is only from -1 to 1, so that I've taken into consideration already here. So till now we have got 3 points of discontinuity for this function: 0, 1 and 1 by 2. So this is solved. Now let us solve for this function, that is 2x minus 3. So at 2x minus 3, what we have actually here is that let us draw the graph for it. Okay, so 2x minus 3 is basically, you can realize that if we take y is equal to 2x minus 3, just 2x minus 3, you should be familiar with the graphs. We are preparing for advanced. So we put x is equal to 0 here. So what I get y to be equal to, that is -3. So that point will be somewhere here. And we put y is equal to 0, we get x is equal to 3 by 2. That would be somewhere here, anywhere on the x-axis. So basically the graph would in turn somehow to be like this. But we need to find out the modulus of this graph. So the modulus, what it will do? It will take the lower values, that is the negative y values from here, and turn it up in the above direction. So basically where we have here 3 by 2, now it becomes like this. And this graph goes like this. The lower part becomes positive now, so it has to go above. So we get this as the final graph. Now you can see that x belongs to 1 to 3. 1 would be somewhere here, 3 would be somewhere here, like this, let me say. So you can see that there is no point of discontinuity here. This may be a point of non-differentiability, but we are dealing with discontinuity here. So there is no point of discontinuity in this function because there is, what is basically discontinuity? Whenever we are trying to draw a function, we just pick up our pen and take it once again. So whenever you go on from here to here, we have no picking up of pen from the paper, and hence there is no point of discontinuity. So there is no point of discontinuity here. So what are the total points of discontinuity for this function which was asked in the question? That will be equal to x is equal to 0, 1 by 2 and 1. That are these 3 points. Okay, so I hope you have realized that what we have done. Let us move on to the next question. Now third question is a very great question. Once again, we have been given that the range of f of x, the function is this. We need to find the range. First of all, the function is ln x into ln x square. Learn the difference between ln x whole square and ln x only square of x. So that is why I've taken this question specially. You should know the difference. And plus ln x cube plus 3 upon these things is expressed as a by b comma c by d. So this is the range of the function that is given to us, where a, b, c, d are prime numbers basically. Then we need to find the value of a plus b plus c plus d by 2. It is the type of integer question. Here we have been given that x is greater than 0. So this is once again a very important condition which should be known to you, that x has to be greater than 0. So let us see to it. So first of all, we have f of x. It can be written as ln x into ln x square, can be written as 2 ln x plus ln x cube can be written as 3 ln x plus 3 upon this can be written as ln x whole square. This can be written as 2 ln x plus 2. Now similarly we can resolve this thing to be equal to what? That will be equal to ln x whole square. So in the side, let me assume that let ln x be equal to some t, because that will be easier in solving the question. So it will become 2t square here, this will become 3t, and this will become 3, and lower side we have t square plus this will become 2t, and this will become 2, that is all obviously 2. Now we can see here that we have got this thing. Let me take the f of x to be equal to some y. Now what I have done here, why x greater than 0 is important, because this thing has this inside thing, the inside thing which comes out to has to be always positive. But if we had taken 2 outside here and x would have been less than 0, then this thing would have been negative, and that wouldn't have been useful for us. So we should know that this thing has to be positive. That is why x greater than 0 part is important for us. Let us deal further. So 2t square plus 3t plus 3 will be equal to yt square plus 2yt plus 2y. Okay. Now this question is very important. We are dealing with log here, we are dealing with functions here, we are dealing with ranges and domains here, and finally we are dealing with the quadratic also. So we take these things here, or let me say we take these things here. So we get t square into y minus 2. We are trying to form a quadratic here, plus 2, let me say t is outside, we get 2y minus 3. This thing, these two things are taken, and finally from here we get 2y minus 3 is equal to 0. Now we have formed a quadratic in t. So whenever we get a quadratic in any terms and we want that the solutions for this thing should exist, so how the solutions can be made to exist? The d has to be greater than equal to 0 if the solutions have to exist. What is d? D is basically b square minus 4ac. We say that the solutions exist for this thing, then the b square minus 4ac has to be greater than equal to 0 in order for the solutions to be there. So we have b square minus 4ac to be greater than equal to 0. So it becomes 2y minus 3 whole square minus 4 into a is this, that is y minus 2 into c is 2y minus 3 has to be greater than equal to 0. Now we take 2y minus 3 common from both the sides. Here we get 2y minus 3 and here we get minus 4y plus 8 to be greater than equal to 0. Further we can resolve it as 2y minus 3 and this thing becomes minus 2y plus 5 has to be greater than equal to 0. Now what I do is that whenever we solve the linear inequations here, we try to make the coefficient always positive. Here we have the coefficient positive for the y. Here also the coefficient should be positive. So what I do is that I multiply by minus on both sides. So what I get, 2y minus 3 into 2y minus 5 has to be less than equal to 0. So from here what I get on the number line, the number line gives us, this thing will give us 3 by 2 and this thing will give us 5 by 2. So now it has been less than equal to sign, so plus minus plus, so the minus sign is here, that is less than equal to 0. So from here we get the value of y which belongs to 3 by 2 to 5 by 2. So 3 by 2 to 5 by 2 is basically what? This is the range of the function because we have assumed it to be y and we get this to be the range of the function. And what has been given that it is expressed in form of a by b to c by d, where a, b, c, d are prime numbers. We need to find the value of sum upon 2. So from here a by b to c by d, we get the value of a to be equal to 3 and we get the value of b to be equal to 2, c to be equal to 5 and d to be equal to 2. So now let us add all of them. So 3 plus 2 plus 5 plus 2 upon 2, that is given in the question. So we get 8 plus that we get 6. Okay, so the final value comes out to be 6. So that has been asked in the question. Once again a very good question for JEE Advanced. The answer is 6 for this question. So let us move on to